beat you so far?
No one's ever beat me. Someone came really close last year, like 4 cells away. I forgot who it was. Someone almost got me last year. I was nervous. That's why I was nervous. I always get nervous when I do this because like I don't want to lose. So here's what happens. What we're going to do today is we're going to use this formula in conjunction with the formula that we had used yesterday to solve some other problems. So let me show you an example. For example, we're going to take this arithmetic series, 4 plus 7 plus 10 plus 13 plus 16 plus 19 plus blah, 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 blah. The difference, remember, between a series and a sequence is the whole addition symbol. That's the only difference. That's what makes it a series. So in this case, it's telling you right off the bat that it is arithmetic. Since it's arithmetic, that means I can write the rule for the nth term. So as we go through these things, we're going to set it up very similarly to what you guys were doing yesterday when you had when you're just given the sequence. Okay. Yesterday, when you guys were just given the plain old blank sequence, having to write out the rule for the nth term, you always started with writing out the nth rule. So if I go to start out by writing out my nth rule here, I know that the nth rule is the first term plus, n minus 1 times the common difference. Now, in this case, what's my first term? 4. What's my common difference? Good. So some quick distributing and combining like terms. Hopefully you get 3n plus 1 for your nth rule. Does everybody agree? Okay. So your nth rule here is 3n plus 1. That hasn't gotten me into the sum of the series yet. But I'm going to need to use that in the formula. Let me show you how that works. If I want to find the sum of 30 of them, I'm looking to find the sum of 30 terms. The sum of 30 terms, the arithmetic sequence, has the same formula as the n first term plus the nth term over 2. Now, what's my first term still? 4. The a sub n is still 4. Oops. A sub 1 is 4. What's the value of n going to be here? 30. Good. So the value of n is 30. That means I need to figure out what a sub 30 is going to equal. And I get that from there. I need to figure out that term eventually anyway, so I might as well take a second to write out the rule to use it. All right. So the 30th term in this sequence would be, well, a sub 30. 3 times 30. 91? Okay. So I know that my 30th term is 91. I now have enough information to fill in all the blanks for the sum of 30 terms. The sum of 30 terms is, well, I need 30 of them times 4 plus 91 all over 2. What is half of 30? 15, and then 15 times 95 is? You were saying it. It ends in your most favorite number in the whole wide world. Yeah. Use your calculator, guys. I don't know what's off the top of my head. 14.25. I was, you know how it ends in your favorite number, 25. So the sum of, if I took 30 numbers in this sequence, 4 plus 7 plus 10 plus 13 plus 16 plus 19 plus 22, 25, so on and so forth, for 30 of them, added them all together, I get 14, I wrote 20, I'm sorry, 1425. You get 1425. That's what that means. Okay? It's nothing more than direct substitution using two different formulas. The weirdness is involved with part B. Part B is asking you the question, find n such that the sum of that many equals 125. In other words, it's asking you how many numbers would you have to add together within that sequence to equal 175. You're trying to figure out how many of them in that sequence you'd have to add together. You're going to have something short.
Does that make the n, if you were to make it like, does that have the same whole n rule as it did in the first?
Yes.
Okay.
Because, and that's a great question, because what's happening here is you're still using that a sub n, because it's still part of the same problem. And you're seeing where we're going, and that's good. Here's what he's saying. I'm just going to copy and paste a couple parts out of this real quick to the next page. We'll call this F. S sub n is that formula. I'm going to figure out how many of them has to equal 175. I want to find the n value that gives me 175. From a little while ago, we knew what the first term was in that sequence. It was 4, right?
Yeah.
So I know that the first term is 4, and I also know that the rule for a sub n is 3n plus 1?
Yeah.
It was 3n plus 1. Are we okay with that? Substituting what we have, we wind up with 175 is n times 4 plus 3n plus 1 all over 2. I don't know about you, but I want to get rid of that divide by 2. Yep. If I multiply both sides by 2, does it go away?
Yeah.
All right, double 175, what do you get? 350.
Oh, I did.
Are we okay with that? All right. Now, in the numerator on the other side, does everybody agree that it's n times the quantity 3n plus 5? What would I do with that n?
Square.
No. You're on the right track. I
Divide
can
by-
distribute. Because right now I'm at this.
This is when the factoring comes.
This is where the factoring comes in. When you are factoring with the equal sign, if you remember, you got to get one side equal to
0.
Good. Because you're, in essence, you are finding your intercepts. You are finding your zeros of this equation. Okay. Now, what kind of a graph does this make? Do you remember?
Parabola.
A parabola. Is it up like a cup or down like a frown?
If it's positive, that means it's down, right?
Is being negative a bad thing? Does that make you sad if you're negative?
Yes.
If somebody kicks your dog, are you happy or are you sad?
I'd be confused.
Depends if the dog ate your dinner or
I
something.
say no. I say no. I say I would be happy.
Wait, so you're saying you would be happy if somebody kicked your dog if the dog ate your dinner?
No, kicking your dog is a bad thing.
Yeah, but you said
And he said
unless
you'd
the
be
dog
happy.
ate your food.
I'd be sad. if my
It's
dog-
still
Okay.
kind of animal abuse. I mean,
I
you
said
go to
I
jail for
said.
that.
I don't know what you're
All right. Bad analogy.
Who's talking about kicking?
All right. Now, hi guys. We all agree this is a parabola. Parabolas are curves. They look like that. Parabolas can be either up like a cup or down like a frown. And someone said over here, it's down like a frown if the first term is negative. The first term is not negative, so it's up like a cup.
Yes, I was right.
Another thing that you might remember when you're dealing with a parabola can do a couple of things with the graphs, with the XY graph. It can touch it in two places, it can touch it once, or it can not touch it at all. In this case, it's not touching it, which means that there's no zeros to the function. It can't be factored. In this case here, it touches it at one spot, which means there'd be 1 0. It can touch it at two spots where I can have 2 zeros being negative. It can touch it at two spots where 2 zeros are positive, or it can touch it at one of each. Obviously, this is not going to be a no solution style problem. So if I'm looking at that term that I have to factor, will it have 2 negative solutions, 2 positive solutions, or one of each?
One of each.
Why?
Because there's one number with a negative.
Yeah. One dead giveaway here, guys, is that since I've got 2 different signs here, that means I'm going to have 2 different zeros. Okay? Now, the tricky part. When you go to factor something that has a leading term coefficient that's not equal to 1, it's awful. It takes a lot of time. You got to make those T-charts and go through that. Or calculator.
This was Luna taught us. I remember this one thing.
I want to explain to you what this is doing here. When we're working with this sum of arithmetic sequence here, series, excuse me, we're trying to find out how many of the numbers in that sequence would I have to add together? How many terms will it take me to get to 175? Well, can I add negative terms if I'm starting with term number 1, then I go to term 2, term 3, and term 4? No. So what I'm doing here is I am going to be looking for a positive 0 of the function. Here's what we do. We type it in, 3x squared plus 5x minus 350. And I don't care what the graph looks like. I'm going to go right to my table. Second table. What I'm doing here is I'm going to look for 0 in my y column with a positive x number. That means you have to add up how many of those numbers in that sequence to get 175. 10 of them. I'd have to add 10 numbers in that sequence to get 175. Not,
Is it not yet?
it was fun.
We have to factor.
We will have to factor a lot more. We will do a lot more factoring later on. This is just one of those first sections that we're just looking for that positive 0, so that it doesn't work. We don't have to worry about so much craziness. Yeah.
So, I don't know if it's the negative or positive.
Oh, wow.
What I want you to think here, one second, don't lean on the chairs. This sequence was what? 4, 7, 9, blah, 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 blah. The question is asking you, how many of these would you have, how many of these terms would you have to add together to get 175? When you start with term, this is term number 1, term 2, term 3, term 4. Do I ever have negative term? That's why I'm looking for positive value. Does that make more sense? Be a positive, happy person. You're going to be all right. Okay? Let's try another one. Same basic principle here. What I'm looking at here is I'm going to figure out what is the sum of the first 20 numbers within the sequence. After I figure out what the sum of the first 20 numbers is within the sequence, then I'm going to ask how many of those numbers in the sequence would I have to add together to get 366. All right? So I'm going to find the sum of them. The sequence starts at 3, 8, 13, 18, 23. Which means when I start with that problem, just like we did yesterday, I'm always going to start by writing out my nth rule, which means I'm going to write out the formula. A sub n is first term plus n minus 1 times my common difference. What's your first term? 3. What's your difference? 5. Very good. So we have 3 plus n minus 1 times 5. What's that?
Times 5.
So from there, when I combine my like terms, do you guys get 5n minus 2? Yes. Good. So your nth, the rule for the nth term is 5n minus 2. Now, in all honesty, you don't always have to do that, but it makes your life a lot easier for part B. That's why I always do it. By writing out the rule first, it just makes it easier for later on. Right, that's all it is. It takes no time at all, given all that information to write it out. So now when we want to find the sum of 20 of them, well, the formula for the sum of 20 is n, first term, that 20th term, all over 2. Because this is going to be a 20. The 20th term will be 5 times 20 minus 2, otherwise known as 98. The first term was, so sum of 20 of them will be 20 times 3 plus 98 all over 2. How do I know what?
How about like the end on the other side of the percent more stuff? How do you know that's also 20?
Because you're trying to figure out, it's telling you that you're trying to find the sum of 20 of them. So this term here is the a sub n. It's the 20th
Yeah, no, I
term.
mean the n outside of the parentheses.
It's the same n, because you're trying to find 20 of them.
It's like in the one we just did, it was like the 30th term, like 91 was not. Like why wasn't that 32?
No, the a sub n was the 91. The n value was still 30. Let me finish this and I'll show you. Okay. What's half of 20? What's 3 plus 98? 101. Add a 0. Good. Tomorrow.
I like it when we smile when we finish the part. It makes us happy. Because we're so happy.
Okay. Now, when you go the other way, this is what you did. That was a sure-ish, I think. It's the first one you did, so by the time you do 2, 3 of these things, it's Part B. Yeah, 8s and 9s, they look the same. I'm sorry. Part B. How many of them do you have to add together to get 366? Well, to find the sum of some number to get 366, that means I'm still going to use my sum formula, which is n, first term, a sub n over 2. And I know my a sub n rule, and I know that my first term was 3. Right?
C.
No, it's 3, not C. So that's the n. First term was 3. The rule was 5n minus 2. That's all over 2. Get rid of that 2. Very good. Get rid of the 2. What is it?
732.
No, it's 234. I'm so easily amused. Did it need? Did you guys agree that it's 5n plus 1?
What?
Yes.
Distribute out the n, you get 5n squared plus n.
Yes.
Set aside equals 0. And then what are you going to do? Yes, sir. Okay. Use your calculator, see what you guys come up with.
I was just copying. I think we had about the same.
What you're looking for is you're looking for a 0 in the y column with a positive x. Did you type it in correctly? Did you use a subtraction symbol, not the negative symbol, for the minus 732?
I told you subtract.
I got 12.
Oh, that's fine.
Sorry.
Are you guys getting 12? No, who's not getting 12?
I figured it out. I was looking for 0 in the x column.
Are you back to where
I like it. AJ. That sounds hard. I like to
Yes.
So when you guys yell at me, that lowers my ability to learn.
So Lloyd was using the word for me moving away from you so I can raise my
I was
ability to
trying to make
learn.
a way for you guys to go and look at yourself.
Not so bad?
Wait, no, I don't know what myself now.
It's here you have 3 plus 3 minus 2 is 1.
12.
I'm a smart.
SMRT.
No, I don't like
Do those por favor.
Poor faith. I'm in
Andy.
front. I'm in front.
Okay? So the first 5 of those are the exact same thing we've done, and then the last 2 of them mix it up a little bit with a very, very simple word products. Yes.
Word problem indices.
As in word problems as do re mi.
Homework tonight.
There's A, B's, and C's in that, I think. Like letters. If they say solve the following, there's a bunch of letters in it, right?
I read the story, but I feel like I'm in a lot of trouble like figuring out what goes where. Like,
What are we doing, G? Hey, Mr. Murphy.
I'm struggling to like find like things that like get back to me.